Hi, fifth graders. Today we are doing our first video for you, and we are going to be focusing on decimal multiplication. Our objective for this video is by the end of watching this video, we want you to have a better idea of how to multiply multi-digit decimals. So basically what we've done so far is we've multiplied whole numbers. We've done 2 by 1, 2 by 2, 3 by 2. Okay, and also in our last base 10 unit, you guys mastered using decimals. So we have some really good models for you to take a look at. Please take a look at this video about twice and take notes as you go along, as we will be going over them tomorrow in class. So here we go. Miss Granquist is going to take off with our first look at a model.
Okay, so here is one of the first problems we'll do. 3 5/10 times 1 4/10. So if you're going to estimate where you expect your product to be, I would probably round 3 5/10 up to 4 and 1 4/10 down to 1. So I would expect my answer to be about 4. And so then let's take a look at this picture model. We're going to talk about these picture models more in class tomorrow, but just to get it in your head, let's take a look. This right here has a value of 1, and this is 4/10. So this entire side is 1 4/10. Okay, it's 1 and then some. That's down in our array. We're going to be going across. Here's 1, 2, 3 wholes, and then the remaining 5/10. Okay, so this array shows us 3 5/10 across, 1 4/10 down, and this is really similar to our whole number method for using the picture. So now in our answer, we have 3 wholes. We have 1, 2, 3, 4, 5, 3, 12, and then 1, 2, 3, 4, 5. So
12 and 5.
17 tenths, which is all of this, right? This right here and this are all of our tenths. And then we have 1, 2, 3, 4, 5. By 4, we have 20 hundredths. And to find our answer, we would simply add all of those together. So as our prediction was, we stated that it would be around 4. The majority of this array is our 3 wholes and then some. So I think that our estimation was correct.
Okay, so our final answer for this one is going to be a little more than 3 wholes. Okay, so the next thing that we want to show you is what it looks like to actually multiply decimals on paper. And the great thing is that you already know most of how to perform this. So just like Miss Granquist started with, we always want to estimate what our answer is going to be. So again, just like in the last problem that we were just looking at, these are the same numbers. So 3.5 we're going to round to 4, and 1.4 we would round to 1. Okay. And 4 times 1 is going to be about, 4. So we know our answer is going to be in that general area. So what I want you to do is pretend like you are multiplying these decimals. We're going to kind of imagine that these decimals are not here at all. And we're going to multiply these 2 by 2 numbers normally. So in normal 2 by 2 multiplication, we take the 4 and we multiply it by the 5, which is 20. Okay, we take the 4, we multiply it by the 3, which is 12. 12 plus 2 is 14. Okay, then we put in what my class calls a happy 0, or that placeholder. Okay, and we take 1 and multiply it by 5, which is 5, and 1 multiplied by 3, which is 3. And then, kind of like these are our partial products, we add them up. 0 plus 0 is 0. 4 plus 5 is 9, and 3 plus 1 is 4. Okay? Now, if you look at our total right here, you'll see that we have 490. You should be thinking to yourself right now that it makes sense that 35 times 14 would be about 490. But if you remember, we took out the decimals. So we need to account for the decimal places to go back into our number. How do we do that, you might be asking? So here's what you do. I'm going to take an eraser, and I'm going to take away my marks. Now, when we take 3.5 and make it into a whole number, into 35, we made the decimal move from here out of the number. Okay, and we know from our last unit that when we can move decimal points, but each time we are multiplying or dividing by a power of 10. Okay, and 1.4 can turn into a whole number of 14 by also multiplying by 10. So that's how we got our two whole numbers. Now we have to look in our answer. Okay, we have a whole number here, and we need to turn it back into a decimal. So what we do is we multiplied by 10 one time, and then we multiplied by 10 again. And we all know from our decimal unit that 10 times 10 is 100, or 100 times. As you already know from our last unit, 490, we have an invisible decimal point at the end of the number, and we want to make it 100 times smaller. So we move it once, which is basically dividing by 10, and we move it again, which is dividing by 10 again, which gives us our 100. Okay? So our final answer for 3.5 times 1.4 is 4.90. Okay, so I know I went through that pretty fast, but we're just showing you that decimal multiplication and whole number multiplication are very similar, and the only new thing that you need to know is how to move the decimals. Okay, so let's take another look, because we blew through those two pretty quickly. So let's take a look at another example.
Now this one's a little bit different because in this last one it was basically like we were multiplying a mixed number, 3.5, by a mixed number, 1 4/10. But in this example, we're going to be multiplying a whole number times a decimal. You can think of it like a whole number times a fraction, the fraction being 1200ths, right? So we can show this in a pictorial model by thinking of it as 4 groups of 1200ths. So let's have one group of 1200ths. Here's 10 hundredths, 1200ths. Here's my second group, 10 hundredths, 1200ths. Here's my third group, 10 hundredths, 1200ths, and my fourth group. So this is 4 groups, 1, 2, 3, 4, and each group's size is 12 hundredths. So now what you would do is think about what would your product be if you were to add these values, repeatedly add these values. Well, you would not get a product over 1. You would be adding 12 hundredths plus 12 hundredths plus 12 hundredths plus 12 hundredths. That would not even give you 1. You wouldn't even be able to fill up a full 100 block with this value. So you can see that multiplying by decimals can sometimes give you a very small product. When you have 4 groups of 12 hundredths, your product is not very large.
So let's look at these same two numbers, okay? And let's look at it when we multiply with the traditional way of our traditional algorithm. So what I want you to do, just as we did last time, is I want you to pretend like the decimal, we're not going to use it right now. We are going to pretend to multiply as we do traditionally, and right here you see that this is a 2 by 1, okay? So 4 times 2 is 8, and 4 times 1 is 4, okay? And obviously I'm going to keep the 0 out for right now because we don't need to multiply it, it would just be 0, okay? So now we have to get back to this pesky little decimal. What are we going to do with that? Well, we need to look at how many times did we need to change the number. So if we're multiplying 12 times 4, we get 48. Except for if you see in our example, we have 12 hundredths times 4. Okay? So how did we take 12 hundredths and make it into 12, the whole number? Well, we multiplied by 10 once, and we multiplied by 10 twice, which ended up giving us, we multiplied by 100 to get 0.12 or 12 hundredths to the whole number 12. Okay? And if we multiply by 100 to start with, we need to then, how do we get the decimal back into our whole number of 48? Well, we need to then divide by 100. We do the opposite to get it back in. So the decimal, even though it's invisible, is behind the 8, okay, because it's 48 wholes and 0, okay, tenths. And we are going to divide by 10 once, and we're going to divide by 10 again, okay, which gives us our new value of 0.48 or 48 hundredths. Okay, so 12 times 4 is 48, but 12 hundredths times 4 is 48 hundredths. Notice that there's a relationship between our two answers. Okay, the only difference is the placement of the decimal. Okay, so again, the only thing that's changing between multiplying with the regular algorithm with decimals or without decimals is the placement. Okay, so right now Miss G is going to show us one more model, and then we're going to get to kind of reviewing all three.
Okay, so we've done, think about it like a mixed number times a mixed number. We've done a whole number, oh, here it's catching up, a whole number 4 times that fraction, 12 hundredths. And now what we're going to do is, you can think about it like a fraction times a fraction. 8 tenths times 5 tenths. What's going to happen here? Well, we have this model. Think about it as an array, a 1 by 1. So this is just a 1 by 1. Anything in between, anything less than 1 will be a fraction. All right, so let's take a look. Let's have this side here be our 8 tenths side. So here's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths. So I've drawn in a line that goes 8 down out of the 10 that are available to go down. So this is 8 tenths of this block, okay? So now let's take a look at the top. We're going to make this part right here. We've gone 8 tenths down, we're going to go 5 tenths across, just like a regular array. So there's 10 parts. I'm going to count over 5 of them. 2, 4, 5. This right here, we've gone over 5, and there are 10 parts total. So we've gone over 5 tenths. Now let's think about the rectangle that's formed by going 5 across and 5 tenths across and 8 tenths down. So let's complete this model. So there is our array that shows 5 tenths by 8 tenths. And let's see what our answer would be. How many hundredths are shaded? 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5. So that means there's 40 hundredths shaded. Just like the lesson, multiplying by fractions or decimals that are less than 1 don't necessarily give you big numbers. So the idea that you had before that multiplying gives you big numbers, it kind of changes when you're multiplying decimals. Okay, so because this is not a big number. This is actually smaller than both of these numbers. So we have to change our thinking about what multiplication does.
Exactly. Remember, guys, that we're just giving you a crash course on what decimal multiplication really means. So that's okay if you're a little bit confused or if you're a little bit lost right now. We're just trying to plant seeds for what we're going to be doing in class tomorrow. So let's get back to the algorithm again. These are the same decimals that we just worked with, okay? So remember, these have zeros in front of them, but for our sake, we're going to pretend like they're not really there right now, okay?
No donut disease.
Right? So we're going to, again, like we did the last 2 times, the first thing we always want to do is forget that the decimals are there for now, okay? So now we're just multiplying 5 times 8. Wow. Hopefully you guys are yelling at the computer screen right now because that's a basic fact, right? 5 times 8 is 40, okay? How did we get 8? Well, we just multiplied 0.8 or 8 tenths by 10, okay? And we took 0.5 Okay, and we multiplied that by 10, which gave us